Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we have another customer requested topic. Here it is. Global variables versus retained variables in Cscape 10. Well, let's keep it short and sweet. Retained variables maintain their values through a power cycle, and global variables do not. Looks like we're done. Well, it's not quite that simple. There are plenty of things we need to review in regards to global variables versus retained variables. So let's get started and break it down. Today we're going to start, like we always do, with definitions, defining global variables and retained variables in Cscape 10. We're going to talk about when we'd use one over the other, a whole bunch of different situations there. And then we'll talk about, how these variable types behave at power up, at download time, all those sorts of things. And we'll finish up with a demonstration in Cscape 10. Here we go. Okay, before we get started, let's talk just for a minute about the different options that are available in the Horner programming languages in Cscape. Okay, so unlike most manufacturers, the big guys, especially like Rockwell, we didn't completely obsolete or completely remove the ability for our customers to program register-based logic in our controllers, even though it's kind of old-fashioned. So for our customers who just prefer that approach, that option is still available to them, register-based advanced ladder. Now, we've transitioned a lot of our customers, and on this channel we cover it extensively, to use a variable-based language, maybe variable-based advanced ladder, or maybe one of the IEC languages, our standard IEC that features all, 5 different IEC languages. And then we also have an option called enhanced IEC as well. Now, for the purposes of today's discussion, we're going to be talking about variable-based advanced ladder. Even though global variables and retained variables are really types that are there for all variable-based languages. So, but today we are going to focus on variable-based advanced ladder. So let's start out with talking about what are global variables and retained variables in Cscape 10. And again, we're primarily talking today in specifics about variable-based advanced ladder. So these are the two different classifications of variables available in all the variable-based languages. And as I mentioned, kind of snarkily in the open, retained variables are retained through a power cycle or a stop-to-run transition, and global variables are not. And both variable types are configured in the program variable window in Cscape 10, and we'll demonstrate that for you a little bit later. Now let's get started talking about when you would use global variables and when you would use retained variables. So we're going to go through a variety of different scenarios. Now, in general, as long as you don't need to maintain a value through a power cycle, you can use a global variable. And you're going to find that in most programs, a majority of the variables are global. Okay, now let's talk some specific scenarios. Let's start out with a variable that you are creating, or maybe that's already created in the defaults of Cscape, which is tied to a system bit or a system register. These are things like always on, always off, the real-time clock values. Maybe you want to have a variable that's tied to the X and the Y coordinate where the operator just touched the screen. Those are all scenarios where you're going to be mapping a variable to a system bit or a system register. So these can be global. They actually need to be global, and they're always going to be set to the value that they're mapped to. So on that mapping column on the graphic on the screen, you can see the specific system bit or system register that each of these variables are tied to. So again, any kind of system bit or system register will be configured as global. All right, now let's talk about variables that are tied to real-world I/O points. All right, well, with these variables, you, again, program them as global. You type in the name as you add them to the program variable window, and in the mapping column this time, you put in the specific IQ, AI, or AQ register that real-world I/O point is coming from. All right, so that is another example of a global variable. Okay, next let's talk about another real world input, this time an output, maybe a %Q for a digital output or an AQ for an analog output. Now, nearly all the time, these are going to be globals as well, because they're just going to be mapped to whatever variable you create will be mapped to a specific Q or AQ IO point. Now, there are exceptions, and we'll cover that when we talk about the retained discussion. But generally, most of the time, even real-world outputs are configured as global. Next, let's talk about a variable that always initializes to the same value on every power-up and every stop to run transition. Okay, so if this is the behavior you want for a variable, you can configure it as global, and then you have two options for doing that initialization I just talked about. You can do it in logic by adding something like you see on the screen there at the top with a first scan contact and a move block or something like that to set that initial value every time on the first scan. Or maybe more simply, instead of having logic for that particular variable, you can go to the program variable table, and in the init value column, you can place the value you want that variable to initialize at. Okay, so that's a very simple way to go. So in that example at the bottom right, you can see that the valve position will initialize at an integer value of 50. So you've got a couple of ways you can handle that. Another time you will use a global variable is if you have a variable that is being continuously calculated or continuously set. Okay, so every scan, that variable is being written to. So examples of that could be calculations, like I'm doing a oven temperature calculation there on the screen with my example graphic. It doesn't have to be a math block that's doing the moving. It could just be a move block, for instance. But if that value is always being set of that variable, you might as well make it global, because having it maintain its value from the previous scan will have no meaning because it's immediately going to get overwritten anyway. Now, if the value is only sometimes being written, you might want that to be retained. Again, we'll talk about that during our retained discussion. All right, now let's talk about timers. Most of the time, you're going to allocate timers as non-retentive, or basically global. Because in most cases, when you have a power cycle or a stop to run transition, in most cases, whatever your timing is going to be interrupted anyway, so you might as well make it global. Now let's talk about the different scenarios where you would use retained variables. And just like I mentioned before with globals, in most programs, you have more globals than you do retained variables. All right, now let's look at some specific scenarios. All right, let's start with a biggie, and that is set points. So if you've got a process or some sort of machine control where you have set points for the machine, most of the time you don't want those set points to go back to 0 every time you have a power cycle. You want to remember the last set point the machine was running at or the process was running at. So most of the time you want set points to be retained. That's typically a very common variable type, is a set point that you're actually going to be retaining. Okay. All right, now let's talk about a biggie, and that is a PID block, or an instance of a PID block. All right, now each PID block has, I believe it's around 16 variables internally that are tied to it when you assign the instance of the PID instruction. And then there's other variables, the ones you see there on the screen on the outside as inputs or what have you, that are also assigned. Now, included in the 16 variables tied to the PID instance are things like the coefficients for tuning the loop. You don't want those all resetting to 0 every time you do a power up. So therefore, almost always you're going to allocate an instance of a PID instruction as a retained variable. Okay. And then when you assign a separate variable as the set point, you're probably going to want that retained as well. And you might even want, the manual automatic flag to be retained as well. So again, PID is one you don't want to overlook. In most cases, you want that to be retained. All right, now let's talk about counters. In most cases, you're going to want counters to be retained. Now, there's going to be exceptions, of course, but a lot of the time, the value the counter was before power cycle, you want it to start up with after the power cycle. And there are certain cases where you want timers, a retentive timer, for instance, to be a retained variable as well. And I've got an example on the screen of some simple logic that's calculating machine runtime. So there's a timer that's counting up and creating a tick every hour. And then there's a counter that's counting the number of hours for the machine hours. So in this example on the screen, I want both my timer and my counter to be retained because I don't want this information lost on a power cycle. All right. Next, we're going to talk about that rare scenario where we have a digital or analog output that we want to be retained. So in this example I have on the screen here, I have a valve position that I want the valve to start out at after a power cycle. In other words, it's going to start out where it was when the power cycle happened. So in this case, I've got two steps I have to do. First, I have to assign my variable as retained and then map it to the real world IO point. And then the next step is I need to make sure that in my hardware configuration that particular output is set to hold value on a power cycle or on a stop transition. So there's two steps required there. I'll show you both steps in the demonstration. Another example of a retained variable is a scenario where you have a variable that is not continuously being set or not continuously being calculated. So on the screen there, I've got an example where we're keeping track of the max temperature of a batch, all right? But we're of course only doing that when the batch is active, all right? And the batch is not always going to be active. And as long as we want that max temp of the batch to be remembered through a power cycle, then that needs to be retentive because it's not continuously going to be calculated and the batch may not be active on the first scan. So again, we don't want that value to go back to 0, so we want that to be retained. Let's talk about how both global variables and retained variables behave on a download. Let's start with global variables. These are very simple. By default, they're always going to clear to 0. That's true unless you have a value listed for the global variable in the init value column. In that case, of course, it's going to be set to that value on every power up. And then one thing I will mention, and that is you do have the ability to change the behavior of global variables on download if you go to the settings area in Cscape, and I'll show you how to get there, but I don't recommend that you change it. Keep it the way the defaults are. It's much simpler. In the rare case you do have to change it, I'll show you where you can find that option. Now let's talk about how retained variables behave on download. So by default, the retained variables maintain the values they had when the system powered down or when the system went into stop mode. But you do have the ability every time you download, for instance, you also have the ability to either decide to keep your current values for all your existing retained variables or to clear all your existing retained variables. Now, first of all, let's talk about new variables. If I've made a programming change and I've added variables to my system, then those variables are all going to start out with a value of 0 by default. However, for existing retained variables, those by default are going to keep whatever value they had before the transition. But I do have the option to clear those if I choose. There's a couple scenarios in which I do that. One is where I'm downloading a program for the very first time into a controller, and even a controller fresh from the factory has a demo program in it, so I want to start by clearing all my retained variables. However, and the other scenario might be if I'm in the process of doing a bunch of development and I just want to start fresh, and I'll just go ahead and clear all retained variables. But even if I select to clear retained variables on a specific download, the next time I do a download, it will default back to keeping the current values. Now let me go and show you all these things I've talked about in our Cscape 10 demonstration. Okay, so I'm in Cscape 10. Let's take a look at our variable configuration and some other things. All right, let's start down here in the program variable window. All right, I've got it selected here, program variables. And as you can see, I have a variety of different groups listed here, starting with global variables and retained variables. Let's expand global variables first. You can see we've got a bunch of variables here at the beginning, which are system variables that are mapped to system bits and system registers. And these were auto-created in Cscape, so they were there, when I started with a blank program. And at the very beginning are a set of arrays that are tied to real-world I/O, AI, AQ, I, and Q. These are all here by default as well. I can choose to use these or not use these, but they're there by default. Now, the actual global variables that I added myself in my program actually start about here. And again, the program variable window is going to show you the variables in the order in which they were added. So this is where I started adding variables. Now, I started in my case with variables that were mapped to real world IO, as you can see here in this mapping column. Okay, now the order does not matter, frankly. And as you can see down here, I have another real world IO mapped variable that's listed later. And then again, since all these are global variables, they're all going to initialize to a value of 0 on a download or on a power cycle, except this particular one, okay, which has its init value set at an integer value of 50. So in the case of valve position at power up, it's going to be set to a value of 50. So that is the exception to the rule, if you will. And of course, a lot of these variables in the program may have logic tied to them so that they're being set in the program to a specific value, whether that's through a calculation, a move block, whatever the case may be. However, at the top of the first scan on a stop to run transition or a power cycle, these variables, again, other than this one, are all going to initialize to a value of 0. Okay, so those are the global variables in my program. Let me go ahead and close that. Now let me open up the retained variables. Now by default, there aren't any retained variables in your program. So these are all variables that I added in my program. Now I have one that's a little unusual here. I'll go through that with you. So normally all your real world IO mapping is done in global variables. In this case, I happen to have one variable that's retained, which is a real world mapped IO value, which is tied to AQ9. So maybe this is some sort of proportional valve, and maybe in this rare instance, I want the proportional valve to start out where it was when the machine powered down. So to do that, I assign my retained variable here, I tie it to the real world output, and then in this case, I have one more step to actually make it work. And that is, and this is only true because this is a real world output. In that case, I have to go to hardware config, and this happens to be an analog output that's one of the internal analog outputs. And I have to make sure that the hold last value is checked for this analog out. And if it's checked, then the AQ register will hold its last value. And since this valve position output variable that I created is tied to that AQ register, this variable will hold its last value as well. Okay, so these are the retained variables that I've created in my program. Let's just take a look at a couple of these variables, see what they're doing right now. Okay, the first two variables in this data watch are global variables. This is a machine run Boolean, and this is valve position. That's that one that's set to 50 on power up. Okay, and then the next two that I'm listing here, an oven temperature set point and a machine hour counter accumulator, these are retained values. Okay, so let's go ahead and start the machine running. Okay, I'll set this to a 1. All right, let's change our valve position manually here to 75. Okay, and you can see what's going on. These are our current values. Now, if I have a power cycle or a stop to run transition, I would expect that this machine run will turn off. Okay, again, providing there's nothing in my program to immediately turn it back on again. And I would expect my valve position to go to 50 because that's the init value that I've set for it. And I would expect these values would stay the same. So let's go ahead and see if that happens. I'm going to go ahead and stop the controller, and then I will start it again. And then let's go back to our data watch and see what happened. And sure enough, our machine is no longer running because this is a global variable and there was nothing else in the program telling it to turn back on again. And our valve position went back to 50, again, because there's nothing in our program to tell it to do anything differently. And these values maintained the exact values they had before. Okay, now let's say that over the course of my development, I do a program download. Okay, well, let's take a look at what happens or what options I have during a download. So if I press download, all right, you can see in relation to today's discussion, here are the key options I have. Keep current values for all existing retained variables, or clear all retained variables. All right, now, the only time I'm going to want to clear retained variables, usually, is if I'm downloading a brand new program and overwriting an old program. So I've got all new variables and all new program. I'm downloading it into a controller, and it could even be a controller fresh from the factory that has a demo program in it. Okay, so the first time I download a new program, yes, I'm going to clear all retained values. I'll click this button and hit the download. And then therefore all the retained variables will start out with a value of 0, which is what I want for a brand new program. Now, on subsequent downloads though, I want to keep the current values for existing retained variables. At least most of the time I do, right? There could be scenarios where I want to start fresh or something like that. But generally, I want that one to be chosen. And by default, it's always chosen. So even if you clear all retained variables on one download, the next time you go to do the download, the default will be back where it was. And that we did have a bug in that area in an earlier version of Cscape, but with the current version of Cscape that is currently shipping out there, 10.2, that's all been fully corrected. So anyway, so that's your download options that you have for your retained variables. All right. Oh, one other thing I want to show you. Now, this is not recommended, but let me show you where it's located in this rare case you want to make a change to how global variables are handled. If you want to change how global variables are handled, you can go over here to the Wave menu, click on Settings, and then in Compiler Options, you can see you have some options to change how global variables behave. I don't recommend any of these, but they're here in the rare scenario where you actually want to use them. All right, I just wanted to show you where those were located. All right, so that's our demonstration, our look at retained variables and global variables and how they behave in Cscape 10. So that does it for our technical content for today. Don't hesitate to get to our website and sign up for training. We've got a couple courses coming in the first quarter, a basic course in mid-February that's filling up fast, and an advanced course in mid-March. All right, there's lots to see and lots to interact with online with Horner Automation. You can go to our website at hornerautomation.com. You can peruse our YouTube channel where you'll find hundreds of different videos, some on specific Horner-related topics and other on more general industry topics. And we're also very active on LinkedIn. Now, next week, we've got a very interesting topic for you. So one of the biggest product releases we had in 2025 were our modular controllers, the CPU 200, 250, and 300. And on first glance, they look a lot like a traditional PLC. So next week, we're going to talk about some of the applications where you would use a modular controller and some of the applications where you would use an all-in-one controller. And the cheat sheet from here is there really isn't a wrong answer in terms of which to use where. We're just going to compare and contrast the two different product categories so you can make an informed decision on your machine as to what type of control is best for you. So go ahead and join us next week for that discussion. Now, if you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do some good.